simple mechanism to make sure that the consumer or the student or the person who is actually preferring is going to be immediately making his or her choice by the very fact that they are revealing. So revealing of the things is actually having the two type of implication, as we said. First one is called the direct revealing, and the second one is called an indirect revealing. Direct revealing, we have already seen that this in a monotonic as well as the convex preference case, if we have actually a choice which is say that if you have two sets of commodity, say x star z and y, then in this particular case direct preference of revelation or direct preference revelation says that when I say given that two commodity xy or xz, then I am saying that I prefer x over z, immediately say that z is not preferred and x is preferred. So z is defeated by an x star. So this is what is actually called the direct revelation. So at the same time, if you have the same, if that is the case, then immediately in the last lecture we have seen that how the preference has been written as well as revealed. So this is actually the standard notation which you can see in the textbooks of different kind. So an indirect preference revelation is such that being categorized or is said such that suppose an x is revealed directly preferred to y and y is revealed directly preferred to z, then by transitivity x is revealed indirectly as preferred to z. This is what is called the indirect preference revelation. So how do we write x I z, or what you do called an x tilde? So you have this kind of a preference. So how do we see that particular things in place? Now in this particular case, an array which is nothing but a magnitude of commodity, all right, of x. So this is what is actually called the vector of x, and in the vector of x we have a point which we believe that the best for that consumer. So in that sense, the consumer is revealed his or her preference to x star, all right, and z was not available, all right. Z is outside the premise of the choice set as far as the particular person is concerned. Now in the second context, y and z is actually given and x is actually not attainable given that y and z ray or magnitude of the commodity. Now the new commodity says that the person chose at point y star, okay, that is when x is not affordable, when y star is being chosen by this particular person. That imply that z is not being chosen by the person, or it is an inferior commodity as far as the choice preference or choice revelation of the consumer is concerned. So that means z is being rejected by choosing y star, okay. Now when we move back the old vector point, that is your x vector. Now in the same x vector y was available, all right. So if the y was available when the x vector was there and you chosen an x star over a y star, that imply that y star is being inferior when you compare with the x star. So that is why we said that y is being rejected, or y being rejected by this particular consumer and chosen for x star, all right. So that is the case. If that is the case, then what happens? Then immediately it gives an implication that when x and y is available, x is being chosen. At the same time, y and z was available, y is being chosen. So in that sense, y is actually superior to z, but that y is being actually rejected while x was being available. So if that is the thing, then indirectly what you are trying to say is that even z was not available in this set, z is indirectly defeated or indirectly been rejected by the consumer by choosing x, or the act of choosing x star imply that z is an inferior commodity. So z is not affordable when x is chosen. At the same time, x star is not affordable when y star is chosen. So x star and z cannot be compared directly. Therefore, but an indirect comparison is possible, and that's what you have a rejection of z in that context. So that means z is indirectly defeated because of the same y which was there in the same set of x, and at that time x is being selected, not y. Therefore, indirectly what you are trying to say is that z is also being rejected. So this is what is actually kind of the understanding direct preference as well as an indirect preference instances when you speak about revealed preference. So two axioms of revealed preference are very important as far as the Samuelson's understanding or the modern social choice theory or the choice theoretic framework which we all adopted to understand the consumer behavior or even the producer behavior. So in that context, we have this axioms to be understood. So let me go to the axioms, because till the last point we had actually come across in the earlier lecture. So for clarification only, I was actually referring this. So to apply revealed preference analysis, choice must satisfy two criteria. Excuse me. Choice must be satisfied um, uh, to apply reveal preference analysis, choice must satisfy two criteria: the weak and strong axiom of reveal preference. Okay, so you might be heard about the weak axiom and the strong axiom of reveal preference, but let me come to the first weak axiom of reveal preference. So what is the weak axiom of reveal preference? If the bundle X is revealed directly as preferred to the Y, then it is never the case that Y is revealed directly as preferred to X. That is, when I am saying that X is directly revealed to Y, I am categorically say that there should not be a case that Y is going to be preferred over X. Okay? It says that when I say apple is better than orange, so I shouldn't make a point that orange is going to be greater than apple in any case. So this is one first point which we have to keep in mind. Okay, so that is the first point which we have to keep in mind as far as this particular problem is concerned. So hello, are you listening me?
Yes, sir.
Very few students are there, only 7 people are here.
Sir, class in present ചെയ്യുന്നുണ്ട്.
Okay, everybody is sitting in the class. Okay.
Yes, sir.
No problem. Fine. So, if that is the case, then your Y X directly reveal preference imply that a Y directly preferred to X is not acceptable. Okay. So this is the first point which you have to keep in mind. So choice data which violate the weak axiom of revealed preference are inconsistent with economic rationality. Now this is the first point or first implication someone immediately derive. That means we have already seen our 7 axioms of rational choice. Suppose such that you reflexive, connected, transitive, causative, transitive, so many things which we have come across: symmetry, anti-symmetry, asymmetry, and intransitive or transitive conditions. So all this is we have already understood. So in that sense, what it means that So you cannot actually say a case that when A is better than B as your revealed preference, then it should not be the case that B is going to be greater than A. That will create a sort of a cyclicity or an intransitivity as far as the assumptions are concerned. Therefore, the direct revelation should not be violated. So if you violate the direct revelation, then that is not going to create a sort of a rationality. This is what is the first and foremost point someone would like to keep in mind. Okay, so that is there, and then the warp is a necessary condition for applying economic rationality to explain observed choice. So this is also very important as far as this particular theoretical formulation is concerned. So warp is weak axiom. Now you may be thinking that why it is weak. When you are talking about a direct revelation, tells that you cannot defeat the other by directly. If that is the case, then why we call it as weak? We should call it as strong, because directly people think that it is directly. So theoretically, it is not like that. We will come across that later. We will actually deal with that later. So the point is very simple. Even if you have an indirect possibility, then that indirect possibility it makes your theoretical formulation more stronger. That is why we call the other more the strong axiom of revealed preference than this one. This is a weak axiom of revealed preference. So the weak axiom of revealed preference is a necessary condition for applying economic rationality to explain observed choice. Directly, we can understand this as, for example, what choice data violate the warp? Let's see this question and see that whether this is going to violate any of our assumptions which we made earlier. So in the graph, you can see that there are two vectors, right? Y vector and an X vector. So X is chosen when Y is available. So X is greater than Y. Suppose if you are actually choosing this particular point, okay, that is X, that green point, where if somebody says that X has been chosen, so it implies that some portion of Y was also there, and still you have been actually chosen Y. It implies that Y is inferior to X. So you have directly chosen it. Y is chosen when X is available. So on the contrary, some other guy who had actually chosen the thing, that is Y. So when he or she was actually preferred Y, at that time some portion of X was also being available in the lower portion of within the Y vector area. Same the case with the earlier case, that is within the X vector area, there is a portion of Y commodity was available, not the complete set. Okay, but still you haven't gone for the first case X, Y, and then the second case X. So these statements are inconsistent with each other. Now, if it is actually about 1%, then the question is that the person is going to be an inconsistent person. While available of X and Y within the vector, some portion of the thing within the vector, there is a tendency that he or she can, be inconsistent, or they can oscillate. They can just shift from one choice to other. If they shift from one choice to other, then the person is not actually consistent. So this is the initial formulation of a rational choice, where people said that this is not possible. This cannot be the case. All right. Because consistency is the most important thing. But consistency as an important axiom is true, but not necessarily, it's a sufficient axiom, but not necessarily necessary axiom. So sometimes people can be inconsistent and they can also have a preference. So this was actually the proposal later mooted by Professor Amartya Sen. But we are not going to the details of that at this point. What we have to keep in mind at the very beginning of the reveal preference proposition, this particular concept is very important because an inconsistent person is actually treated as an irrational person. So therefore, this is a most important axiom as far as the particular framework is concerned. Okay, so we will, when we keep advancing the learning, so we will get to know why this is a problematic one. Okay, so checking if data violates the WAP, the consumer makes the following choices at prices P1, P2. Now let's have an empirical point, like at price P1 and P2, maybe $2, $2 combination. The choice was X1 and X2, which gives a 10-1 relation. Okay, so this is all arbitrary relations. So you can actually attribute any numbers, you can give any number and make a sort of a matrix. Okay, so we are trying to construct a matrix which try to give a sort of understanding that how the data violates or don't violate certain conditions. Okay, so let us look into the data set. So at P1, P2, that is the second set of case, you have this particular combination of y 5. Okay, now you look into the magnitude, that is the cardinal numbers of the same, it makes no sense. Okay, you have 10 1, that is actually not actually gives the value, it is only your preference. But in the second case you have a 5 5 relation, but in the third point you have depending on the price of the commodity, you have 5 4. Okay, so the 5 4 5 5 10 1 in fact has little value in a cardinal number but of course in the cardinal numbers perspective it has a magnitude problem, but in the ordinal number there is no problem of a problem. So let me, is the warp, now the question is that is the warp violates by this data. So so this is the data which I was talking about. So checking if the data violates the warp. Now you have two type of directions. One is choice, the other one is price. So price is given in the column and choice is given in the row. And you have actually this combination of the two. 10 1 you have if you multiply you will get it, so 22, and the other one you will get 20, the other one you will get 18. Then you have a 2 1 relation, then again you have actually 21, 15, 14, and then you have 12, 15, and 13. So this is actually the data which we had constructed. Now red numbers are cost of chosen bundle. So this is actually the kind of choice bundle in that sense. So you have a cost which is actually for the first you have 22, for the second you have 15, then the other one you have the diagonal choice. So this was 30. Okay. Now right. So you are following it, right? So let's go to the other aspect. Okay. So that now circle around this circled around points like 20, say in the case of $20 and $18. Okay, that is circles around affordable bundle that were not chosen. So in this particular case there are many bundles, as we said, there are many affordable things which you haven't actually chosen. So when 22 things, this 20 and 18 were affordable, but you had gone for 22. Given the second case, what happens? 14. Okay, affordable case. So, but still you haven't. Okay, you've gone for 15, it implies that 14 was affordable. If you've gone for 22, 20 and 18 was affordable, but you haven't gone for. So directly you are defeating it. Okay. And in the 13 case also, you are actually directly defeating the 12, where it was affordable, but you haven't gone for it. Okay. Now this is the case. So where there is no violation, that is directly you defeated these following numbers like 20, 18, 14 and 12. Why? Because in the given set of choice, you have gone for a higher set, which is called the 13. In the last case, 13, 12. 12 was an affordable one where you gone for better choice, 13. At the same time, you also gone for the 20, 18 when you chosen for 22, and 14 was an affordable case when it was 50. So this is why it forms like a direct DDD. Like what do you say is actually, when I made a choice, what I've done is actually I've gone for a better thing as far as this particular combinations are concerned. Okay, so fine. So 10 is directly revealed preferred to 5-4, but 5-4 is directly revealed preferred to 10-1. So the warp is violated in this case. But suppose if you are going to have a reverse case. So this is actually the diagonal example. Okay, so what is that? In this particular diagonal case, if you look into it, then things are going to be little messy. 15 is directly preferred to 12, whereas 15 is indirectly not preferred to 18. Why? Because 18 is better than 15, but still you have gone for 15. So indirectly what it is actually violates the very premise of the preference. So directly it is having no problem, but indirectly if you look into the data set, then you will see that there is a violation takes place. That is at the point when you say that one number is better or your choice is better than the other, then it should not be the case that there is any number which says that your choice is inferior to what you have chosen. So if that is the case, then definitely there is a violation takes place. So indirectly, by the very fact of this particular construct, there is a circularity. Okay, so if you check the same thing in a data set, that is, if we compare the same bundle which is we have constructed, can be actually plotted, and if you plot this, then you are going to have this relationship, that is 5-4 is directly revealed to 10-1, and the 10-1 is directly revealed to 5-4 in that case. Okay, because of that particular point, it just actually lies above the things, but this is possible. If that is the case of 10-1, which is actually the arrow point, where it is definitely a superior point as far as the indifference map conceptualizations are concerned. That is that particular point. If you have an indifference curve, then that point is going to definitely give you a better result than what you think. So if that is the case, then definitely there is a possibility of violation, and if that possibility, there is a definite violation. So if that has been violated, then your whole direct reference is insufficient to say that actually that is weak axiom of real preference is insufficient to say that a choice is consistent. Okay, if choice is not consistent, then it implies that there is a irrationality in choice. So that is what the inherent relationship between these two facts. So in that context only, you introduced a new concept which is called the strong axiom of real preference, which says that naturally, intuitively, you can immediately understand that there should be a case that also ensures that your choice is never ever defeats indirectly also. So if you are not even indirectly, not only you are actually directly defeated, But if you are indirectly also defeated, then your choice is having an inconsistency problem, as I said. But if other way around is the case, then definitely what our proposition is going to, that is the proposition which we are going to moot is going to have the required or the expected result. So this is why the instance where the strong axiom of revealed preference were being introduced, so or was being introduced. If the bundle exists, so let's define that in the following way. If the bundle exists revealed directly or indirectly as preferred to the bundle y, and the y is not equal to x, then it is never the case that the y is revealed directly or indirectly as preferred to x. That is, x directly or indirectly prefers y, or y is indirectly preferred to, sorry, x is indirectly prefers y. It implies that not the case of y is directly or indirectly prefers. All right, so this is what is actually the whole exercise we mean. What choice data would satisfy the warp but violate SAP? So this is the question which normally everyone may be having in mind. So let me come to that case also. Okay. Suppose we have to, for that we have to actually construct a much complex combination. Okay. Not now you have at least you have to have three elements in the set, not two elements, because two elements says only, as we said, you know, that paired combination only says about whether the pair is one element in that pair is superior or inferior, and we always makes a sort of different combination of the same, and then we try to figure it out. But in this particular context, what is the thing is actually you need three uh, elements at least in the set in order to satisfy this particular conceptualization. So let's just have the same uh, kind of, you know, magnitude, and have three price as well as three commodity. Okay, say P1, P2, P3, which is equal to 1, 3, and 10 for x1, x2, and x3, which is actually gives a sort of 3, 1, 4 combination. So this can be anything, as I said, it is only a construction, matter of construction. So there is a B which says 4, 3, 6 for the same the commodity x1, x2, x3, and the result is 2, 5, 3. Okay, and then you have another set of price which is 1, 1, 5, which gives an x1, x2, x3. This is following combination. So for 4, 4, 3. Suppose if that is the case, then you have actually a matrix like this. If you have all this thing, then you add, you multiply, you add all your value, and you will get a combination, a matrix like this. So you have an ABC choice and a price of ABC, and in the first case you have 46, 41, 23. Okay, now if that is the case, you have this particular thing. See, this thing is I'm going to have on the left side. Let me see or whether the situation is actually going to hold on. In situation A, the bundle A is directly revealed preferred to bundle C. See, in this case 46 and 46 are there. So 46 and 46 case, 46 is directly revealed preferred to bundle C. Okay, so bundle C is directly worse than bundle A, because bundle A is being made, it is chosen. All right, so once you make that, then even the number doesn't matter, that's it. Okay, now in that case, what happens to the second case? In situation B, if you have a 39, that is also directly revealed to 41. Okay, And in the 22 case also, you have the, as far as per the assumption, what you are trying to say is actually is being chosen, because 22 is actually preferred over sorry, 23 is preferred over 22. Okay, so you have the case. Now direct reveal the case, that is DDD, all the D circled numbers, which is directly preferred. Only you have three other combinations which is not actually circled. So what they then do not violate. So in that case, it do not violate warp, which is because it is directly revealed preference. Okay, so we have that A is better than C, and B is better than A, and C is better than B. So by transitivity, A is indifference in the second case, A is indifferent to B, and B is indifferent to C, and C is indifferent to A. So the data do not violate the warp, but it violates SAP. So you are indifferent to the other case. So that implies that A is inconsistent with AIB. So you say that A is preferred over B, but at the same time you are saying that A is indifferent to B also. So in that sense, what you are going to do is actually sort of a violation. So in this case also you have a violation. That is, in the CC case, you have the same thing. It won't actually violate a warp, but it violates the strong axiom of revealed preference. What is our case? It should not be the case. The data do not violate the weak axiom of revealed preference, but there are three violations of strong axiom of revealed preference. So this is what is the demonstration try to make, that the observed choice data satisfy the strong axiom of revealed preference is a condition necessary and sufficient for there to be a well-behaved preference relation that rationalizes the data. So our three data cannot be rationalized by a well-behaved preference revelation. That is the result. Now covering the indifference curve, suppose we have the choice data satisfy the strong axiom of revealed preference, then we can discover approximately where are the consumer indifference curves are and how. Okay, the same as I said in a new set of paired observation, you may be having A, B, C, D, E. Now 5 pair. Okay, P1, P2, you have 2P, say, which is equal to $1 in the first case, in the B1 case 2, 1, and in P1, P2 case of C is 1, 2. So then D, you have this thing, and you have a combination of corresponding commodity X1 and X2, and that is gives you the sort of on the right side combination. Okay, so this is also, as I said, it's arbitrary, it's only a construction. Sorry. So where lies the indifference curve containing the bundle A, which is equal to 15, 15. So let us go to this particular question. So the table showing direct preference revelation is this. Now, if you have this combination of P1, P2, okay, with respect to a price, as well as X1 and X2 with respect to its quantity or whatever, the utility or your benefit out of it. So that has been given in the second number. That is the case. Now, immediately if you calculate, just like the earlier combination, you immediately get this table. Okay, so this table, and imply that there is a DD and all other things, because this shaded area, dark shaded area, is what is called your preference, the fundamental preference which you meet, and the corresponding directly defeated elements are there in the columns or cells of DD, all the D's. Okay, that imply that direct revelation solely. the warp is not violated by the data. Now, our question is that whether that is going to satisfy the indirect revelation also. Okay. So if the direct preference revelations add no extra information, so the table showing both direct and indirect preference revelation is the same as the table showing only the direct preference revelation. Okay. Both the direct and indirect revelation neither what nor are violate. So if that is the case, if that is not given, then it is says that since the choice satisfies this R, there is a well-behaved preference revelation that rationalizes the choice. Okay. That means if one commodity of an E, which is the best of that, and then that is not going to basically violate the condition. So begins with the bundle revealed to be less preferred than the bundle A. So let's look into this aspect one by one. Now this is actually the overall picture which the data which we had is going to give. So you will, if you basically draw a diagrammatic, or if you make a diagrammatic presentation of the data which I have given, you will get exactly the same curve. Okay, different curves which is actually intersect each other, and some are going, some are not going with each other, etc. So you will get all this kind. Okay, so if you strictly follow all the possibility. Now, to make it clear of all of you, let us actually construct it in a different way. So suppose if A, the first one, that is P1, P2 is equal to 1, 1, and X1 and X2 is 15, 15. Then you will get a graph like this. Out of that, you pick one point. Okay. So A is, what does it mean? It means that the point A, that is that circle, is directly revealed a preference to any bundle in that. Okay. It implies that anything which comes inside this particular curve or area, A is the best for that particular person. This is what we have learned in the very beginning itself. So out of that, if you say that there is a B exists and there is a C exists, doesn't matter. B and C, everything is going to be preferred. So A is going to be preferred over B and C, if that is the case. Okay, why? Because in the previous, this particular diagram says that within this range, A is the best. Okay. So B is there. Now A is directly revealed preferred to B, and therefore this portion is actually irrelevant. So by transitivity, A is indirectly revealed preferred to bundle in B also. So you have this particular point, right? So this is clear now. So this much of a point is actually comes under this particular revelation. So now in the saffron line and the green line, given that both are available, you still say that your A is better than your B because A rejects even the B itself. Okay, so that's the point. Now, if that is the case, let's look into the C portion C, which is also given earlier. So same logic can be applied here. C is directly revealed preferred to all bundles in that particular available set. But this particular thing was being rejected because that particular point was earlier available when A was being chosen. So therefore, B and C is now rejected because A was being treated as the best bundle. Therefore, the indifference curve contains A must lie everywhere else above this particular shaded set. Now, this is actually makes a lower bound, says that an indifference curve must be above this particular shaded areas of B, A, and C. Okay. Now, What about the bundle revealed as more preferred than A? Now, there are bundles which says that better one. Okay, two bundles. What are these bundle? E and D. Okay, because A, B and C is now rejected. Now only left with is D and E, right? Now, these two curves are very important. Now, let's look into the D. Okay. Now, D is not revealed. Okay. D is directly revealed prefer. D is not being rejected because it was not a comparative point with that of the other. Okay. Now, if suppose D is there and this point of D is actually a different point, which is not interior to A. So if D falls here, that is within the A range, then things would be a different one. But now this consumer's preference, which is D, is actually much far away from what is actually inside the A. Okay. So in that context, what happens is that D is directly revealed preferred to A. So D is a superior one to A, not the other way around. So a well-behaved preference are convex. Therefore, you have this direction. Okay, so all bundles on the line between A and D are preferred to A itself. A and B are A and D, where everything within the A and D set is actually preferred to A. That is, A is inferior to all other points, which is between A and D. All right. So as well as all the bundles contain the same amount of commodity 2 and more of a commodity 1, then D are preferred to D and therefore are preferred to A. Right. So this is what is actually we are trying to make. Any point which is falls above A, that is always being revealed preferred to A. That is, they are better bundles. Bundles revealed to strictly preferred to A. Okay. Therefore, that particular context has been now dealt with. So there is a ratio follows. Now, what about the other point, which is called the E vector? Okay. Now, if you look into the E vector, E is directly revealed to A. Just like the D case, E is also directly revealed to A. So, in the same assumption, if you apply, well-behaved preference are convex. So, all bundles on the line between A and E are preferred to A. So, all bundles containing the same amount of commodity 1 and more of commodity 2, that E are preferred to E, and therefore E are preferred to A. Sorry, therefore are preferred to A. Therefore, you have this particular bundle, range, that is more bundle revealed to be strictly preferred to A. So now you have this thing, bundles revealed earlier as preferred to A when the case of D is there. So at the same time, you have also some portion of E is also be better. So now this is actually the total area in which you can say that people are interested other than A. Okay. Now we have an upper and lower bound. What does it mean? There is an upper bound being created. So as far as this particular individual is concerned, there is an upper bound is set, which is called an attainable point, which you right now you have no capacity, or what you call your income is not allowing, or something like that. Okay, a better bundle which you wish to buy. At the same time, the other points which we set are called the lower bound, that is BAC point, which is actually all the areas, that is the green lines area, total green lines area, and the red lines area, along with the saffron lines area. So all that is actually makes the lower bound. At the same time, all this E a dashed area, which is E and D forms, where A is being the lower point. Any point above that is actually being preferred. So that is creates a kind of, a better possibility or the choice combination which this consumer wants to go. So that is what is called the upper set. Okay, upper and lower bound on where the indifference curve contains a boundary A. Okay, so this is how it is looks like. Now recovering indifference curve, then you can have an indifference curve within this range. Okay, all bundles revealed to be less preferred to A, and all bundles which is more preferred to A. So now you have an upper bound and the lower bound, and there is an area in which your graph will be lying. So that is the green, this green line, this the total military green curve, that is this one. So this region in which the indifference curve contains a bundle A must lie. So where the A must lie is actually only in this particular area. So with this is what is actually how Samuelson tried to prove his point, saying that it is possible to have the same understanding of a thing with the help of an indifference curve, with the help of an ordering, with the help of understanding the upper and lower limit and boundary of commodity choice, and make a point that people can have a preference, and that preference is not going to basically violate neither of these two conditions, like the weak axiom of revealed preference as well as the strong axiom of revealed preference. So this is what is actually about the indifference curve construction. So there's 2 points which I would like to, that construction of the now the most important thing is actually to construct yourself the data, and put magnitudes, different kinds of values, and construct your own indifference curve set in a diagrammatic way as well as in a mathematical way, as well as the schedule which I was trying to show. So you can basically construct indifference curve in this line and have a better understanding. With this, let me stop today's presentation, and if you have any question, I am very happy to answer. So thank you for your patient listening. I'm sorry that I'm not well today, so I couldn't actually come directly and take the class. So thanks.
Thank you, sir.
So if you have any question, you are free to ask. If you have any question, because you may be having a lot of question, because the construction which I made itself may create some sort of a doubt. So if you are not followed things very keenly right now, you can also look into this lecture once I upload, and then in the next lecture you can also ask. So that is also a possibility. But what I feel is that you can at least ask some question if you want to get yourself clarified. Thank you.